this lesson, we're looking at areas of triangles, trapezoids, and rhombi. We're going to find the area of triangles and the area of trapezoids and rhombi. How is the area of a triangle related to beach umbrellas? Umbrellas can protect you from rain, wind, and sun. The umbrella shown at the right is made of triangular panels. To cover the umbrella frame with canvas, you need to know the area of each panel. Lucky for us, we've got a handy-dandy formula. If a triangle has an area of A square units and a base of B units and a corresponding height of H, height is also known as the altitude, then A equals 1/2 base times height. Which would be the same as base times height divided by 2. Find the area of quadrilateral ABCD if the length of AC is 35, BF is 18, and DE is 10. And they gave us two triangles. They gave us the height, or altitude of each triangle, and they share the common base of AC. So we're just going to use the area of triangle formula twice. So the first triangle, 1/2 times the base times, I'll do the top one first, would be the same as, we could cancel the 1/2 and 18 is 9. So 9 times 35 is 315. And area of the second triangle, 1/2, they have the same base. And this one has a height or altitude of 10. We can cancel the even numbers, that's nice. 1/2 of 10 is 5. Just makes a little bit less to type in the calculator. 5 times 35 is 175. So to get the total area, we just need to add the area of region 1, the area of region 2, and we get 490. And we're going to call it units squared because they didn't give us units. Now this actually goes into the next area we want to find quite well, because we want to do trapezoid next, and to do a trapezoid we could break it up into two triangles, like this was two triangles. So to show how to find the area of a trapezoid, if we drew in this diagonal QN, it breaks it up into two triangles. And we already know how to find the area of a triangle. It's 1/2 base times height. They call the bases B1 and B2, and they both have the same height. So then we can factor out, the greatest common factor is 1/2 H, and we have the formula for area of a trapezoid. The area of a trapezoid is 1/2 the height times the sum of the bases. The formula is so easy to use, I guess they thought it'd be more challenging if they made us plot the points first and count squares. So I went ahead and gave us the plotted points and counted squares. From -1 to +4 is 5, and from -2 to +6 is 8, and from -1 to +2 is 3. So now we can plug into our formula. Area of a trapezoid is 1/2 the height times the sum of the bases. And we have odd numbers, 3 and 13. When we type it in the calculator, it's not going to come out even because it's odd. Half of an odd number. It's going to be a 0.5. 19.5, and they didn't give us units, so we're going to call it units squared again. I have a really short formula to find the area of a rhombus. It's just 1/2 the product of the diagonals. Now, if they happen to give us the altitude, because a rhombus is also a parallelogram, we could use our parallelogram formula, areas base times height. Okay, once again, the formula is so easy, 1/2 the product of the diagonals, that they decided to make it more challenging by making us find the length of the diagonals. So if MP is our first diagonal, we do the difference in the x's. 0 minus 3 is going to be -3 squared is going to be 9. And 1 minus -2 is going to be 3 also. Squared is 9 also. So we have square root of 18. We're going to do the same thing for NR. So 4 minus -1 would be 5. Squared is 25. And 2 minus -3 is 5. Squared is 25. So I have square root of 50. And then I didn't even simplify the radicals because I'm just going to plug them in as they are. Square root of 18 times square root of 50 is square root of 900, which is conveniently a perfect square. And half of 30 is 15. And again, they didn't give us units, so we're going to call it units squared. The next diagram's not quite so complicated. Rhombus RSTU has an area of 64 square inches. Find US if RT is 8. Now, they might give you a problem like this without drawing the diagram. You'd have to draw it yourself. That'd make it more complicated, but otherwise it's not too bad. They gave us the area, so I'm substituting that in for A, and they gave us one of the diagonals. So half of 8 is 4, so all I have to do to solve is divide both sides by 4, and we're done. Oh, they even gave us units this time. Inches. Trapezoid has an area of 120, so I'm substituting it into the formula. And they gave us the bases, just have to find the height. So my bases, it doesn't matter which one's which, because we're adding. So the sum is going to be 30. And I just combine those two. Half of 30 is 15. Divide both sides by 15. And our height is going to be 8. And they gave us units. They are feet. So practicing a little bit of algebraic reasoning, but not too bad. The stained glass window is composed of 8 congruent trapezoidal shapes. The total area is 72 square feet. Each trapezoid has bases of 3 and 6 feet, which is always nice to label on the diagram. Find the height of the trapezoid. Okay, first I'd like to know the area of one of the trapezoids. If there are 8 of them, 72 divided by 8 is 9, and I should not have done that because it was feet squared. Tally mark squared doesn't make so much sense for a feet mark. And we can say that because congruent fingers have equal areas. I didn't think that was worth saying on its own. It's pretty obvious, as postulates should be. So the area of one of the trapezoids we found is 9. And we are looking for the height, and we know the bases. Well, that's going to be convenient, because 3 plus 6 is 9. I could divide both sides by 9. So then we have 1 equals 1/2 h. So to solve for h, all I have to do is multiply by 2, and I have h equals 2, and my units were feet. The formula for area of a triangle can be used to find the areas of many different figures, including trapezoids. Congruent figures have equal areas.